Good day and welcome back for the fifth and final part of our discussion on differentiating logarithmic functions. As I indicated at the end of the previous video, there is an associated worksheet which you can find located on Canvas. Hopefully you've taken the time to find that worksheet and you've invested a significant amount of time to work through the problems. There's quite a few problems there, and I do intentionally try to include quite a few problems just to give you plenty of practice that you can work and then compare your work with the solutions that I provide. So with that in mind, I wanted to say something about one of the derivatives and one of the antiderivatives. So 1c asks us to differentiate cosine x raised to the x. When it comes to differentiating this function, I think we have two perfectly good approaches that we've illustrated in our previous video. We could use logarithmic differentiation, or what I would suggest, because it's more direct, is we simply rewrite it in terms of exponentials and natural logs and just differentiate directly. So how we could rewrite this in terms of exponentials and natural logs is it's e to the natural log of cosine x to the x. And note, the reason this is helpful is because this exponent inside the natural log can be pulled out front. So we can write this as the derivative of e to the x natural log cosine x. And this is something which is much more convenient to differentiate. The chain rule tells us we differentiate the outside function, evaluate it at the inside function, and then we multiply it by the derivative of that inside function. And from a procedural standpoint, if you compare this to our previous example where we differentiated x to the x, this is working out essentially the same step for step. Now note e to the x natural log cosine x, if we begin above and we just trace our work back, that is the original function cosine x to the x. So just to make it look a bit nicer, you don't have to, but I'm going to write that as cosine x to the x. And then I'm going to evaluate the remaining derivative using the product rule. Derivative of the first times the second, plus the first times the derivative of the second. And to differentiate the natural log of cosine x, we use the chain rule. Derivative of the outside function, evaluated at the inside, multiplied by the derivative of the inside. And we certainly could do some manipulating and combining terms, but I'm going to leave it exactly in this form. In general, this technique, as we mentioned previously, can be applied to differentiate a function raised to a function. It is a good technique to be familiar with. In problem 3c, we're asked to evaluate this antiderivative, which at face value looks like a rather difficult indefinite integral to work with. But note, if we can recall a few key trigonometric identities, this becomes much simpler. So the two key identities are as follows. So I find the identity that we remember the easiest maybe from trig is cosine squared plus sine squared is 1. So with that in mind, our integrand, the denominator is 1 minus cosine squared. If you subtract cosine squared from both sides, that denominator is now the somewhat simpler looking sine squared. And in the numerator, the double angle formula for sine is something that should be familiar. And a common question students will ask is, what formulas do we need to know or memorize? And I would say if we've seen something in class or on homework or in worksheets, that certainly means it's fair game to be encountered later on. So the Pythagorean identity and the double angle formula for sine are things you could add to your overview of important formulas and properties that we've encountered. And sine of 2x can be written as 2 sine x cosine x. So that's the double angle formula for sine. And the reason this works out nicely in our current example is we have a sine x in the top and a sine x squared in the bottom. So we can cancel off one of the sines in the top and the bottom, which leaves us with two indefinite integrals of cosine over sine. And to continue on evaluating this, what technique of integration would you recommend? A substitution would be somewhat ideal. If we let u be the function in the denominator, du is simply cosine x dx. So we're left with two indefinite integrals of 1 over u, which is 2 natural log absolute value of u. And we remember to resubstitute and get it back in terms of that original variable. And just to reiterate some earlier comments, a very important part of the learning process is practicing. We can get some good practice working through these worksheet problems. You also have a large number of suggested problems. I don't suggest that everyone completes every problem, but we should be doing enough problems to get an understanding and feel comfortable working with these new techniques. And when you encounter questions, do not hesitate to drop me an email or stop by office hours. So stay tuned and take care.